Welcome to Pamita AI World 18. My name is Pamita Singh Kandari and you are watching my YouTube channel Pamita AI World. So all those students, welcome to my channel. So in my previous video, all the English medium students, in my previous video I was teaching you about the Kendall-Stowe correlation coefficient, and I have announced in that previous video that the next topic would be spearman correlation coefficient. And in spearman correlation coefficient, before teaching you the spearman correlation coefficient, there is some theoretical part you all students should know, so that you don't get confused when I'll teach you the basic when we'll jump to the mathematical or part of the spearman correlation coefficient, because it's a bit difficult topic to understand. So I'll try my best to teach you in a very simplest way. So what is correlation? Although correlation I have taught you in my previous video in detailed way, covariance and correlation, please check this video before jumping to this video, but here I'll give you the quick revision about correlation. What is correlation? Correlation is it determined how closely two variables fluctuate. What are variables? Let's consider that the variables are let's take variable of sugar. Fine. If you will one is the variable is sugar and another variable is weight. Fine. Weight of person. These are two variables in a topic. Fine. Let you guys understand this way. It determines how closely two variables fluctuate. If you eat more sugar, your weight would be increase. Fine. Sugar increase, weight increase. Sugar decrease, weight decrease. Fine. So sugar and weight are two variables. So what is correlation? So there is positive correlation between the sugar of the person, sugar intake taken by the person, and the weight increase or decrease of that particular person. So it determines how closely two variables fluctuate. Fine. Now these things would be correlation would be two types. One is negative correlation and second is positive correlation. So negative correlation, one variable increase as other decrease. Fine. I have given you the example of sugar and weight is the example of positive correlation, in which both variables decrease or increase parallelly. Sugar intake increase, weight increase. Sugar intake decrease, weight decrease. So what is the example of negative correlation? Negative correlation example is in which one variable increase as other decrease. Let's take the example of negative correlation. If you will walk faster, fine. If you will walk faster, your weight would decrease faster. Fine. If you like walking faster, but weight is decreasing. So what is that variables? One variable is increasing, another is decreasing. So that would be considered as the negative correlation. This is the example, although all these things I have taught you in my previous video. Just to tell you that what is how spearman rank correlation is interrelated. So the example of correlation is related to the positive correlation. Fine. One such correlation is spearman rank correlation. Understand? So correlation definition I have given you here. What is negative correlation, positive correlation, and spearman rank correlation is related to the positive correlation. So spearman rank correlation, what is that spearman rank correlation? Now we'll understand the theoretical part of it. So before understanding the spearman rank correlation, we should know first that what is monotonic function. What is monotonic function? Before teaching you the SRC in a detailed way, I'll teach you what is the function. Fine. Monotonic function. So it is nothing. Monotonic function is nothing. It is one that either never decrease or never increase as its independent variable changes. What does that mean? Monotonic function is that which never increase or never decrease when two variables independently increase or decrease. What does that mean? Let's understand it through the graph. Look here. This is the graph of monotonic increasing function. Monotonic increasing function. Here what is happening? If x is increasing, this is the x variable and this is the y. X-axis, y-axis, or you can see that this is x variable and y variable. Fine. If x is increasing, let's say 1, 2, 3. Here 1, 2, 3. If x is increasing, 2 is x, then y is also increasing. Monotonically it is increasing. Fine. So we can say that if x is increasing, variable y never decrease. Fine. By seeing this graph, we can say that if x is increasing, likewise, so y is also increasing. It is never decrease. That is called monotonically increasing function. But now comes to monotonically decreasing function. Here what happens if variable x is increasing here, let's see, if x is increasing, here x is increasing, fine, here x is at 1, here x is at 1, where y is? Y is here, fine, here again x is at 2, but y is at same place where it was previously. So here what is happening? Here x is increasing, but y is not increasing. Fine. Monotonically it is not increasing. Fine. So that is called monotonically decreasing function. And in third paragraph, what we are saying, that there is no correlation with the monotonic function. Whether it is what is happening in this graph, here if x variable is increasing, somewhere y is increasing, somewhere y is decreasing. Fine. Here x is increasing monotonically. You can see x is increasing here, x is increasing here. It is continuously increasing. But what is happening to y variable? Somewhere it is increasing and somewhere it is decreasing. Somewhere it is again increasing, somewhere it is again decreasing. So that is called the monotonic function. You, all the students who are learning spearman rank correlation, I know this is bit difficult topic, but just to all the guys understand, before jumping to the mathematical expression, you should know that what is monotonic function, and I have teach you the simplest part. So this is all. A monotonically increasing function, this is the theoretical part where I have written, as variable x increase, the variable y never decrease. This is the graph of that particular thing. This is the theoretical part I have written here, and this is the graph. Again, monotonically decreasing function is what? If the variable x increase, then y never decrease. That is called monotonically decreasing function. This is the second graph, and this is first graph, and this is third graph. Now, as the x variable increase, the variable sometime decrease and sometime increase. So what is this? This is the third part of the graph. This is third part of the graph. Fine. This one I am talking about. Now what is SRC? SRC is nothing but it measures the strength and direction of association between. SRC is spearman rank correlation. It measures the strength and direction of association between two ranked variables. So till now you all the students could understand spearman correlation coefficient is nothing but it tells the strength and direction of association between two variables, and these two variables are not simple variable, but they are ranked variables. Fine, they are ranked variables. Now we will understand what that rank variable after. I'll erase all those things, theoretical part. Now how well the relationship between two variables could be represented using a monotonic function, that is called spearman rank correlation coefficient definition. This is the definition of spearman rank correlation. Fine. And now we'll jump to the formula. What is the spearman rank correlation coefficient formula? Sometimes what happens in interview, when you go to the interview of data scientist, sometimes they ask the formula also. So what is the formula of spearman correlation coefficient, or else they will give you the data or data sets, and they will ask you calculate the spearman rank correlation coefficient for that particular data. So you should know the formula also. So what is formula? Formula is 1 minus 6 summation of di. Now what is d? D is nothing but difference between two ranks of each observation. Fine. Just understand that particular formula and read that formula in now. After erasing that particular thing, I'll teach you the basic with the example so that you can understand. So 1 minus 6 summation of d is nothing but it is the difference between two ranks of each observation. Fine. And what is n? N is the number of observation. Fine, all the students. So this is the only theoretical part you all the students should know. What I have taught you till now, I have given you the example of correlation. Correlation is what is correlation's definition, and what are the types of correlation. There are two types. One is negative and one is positive. So among this positive correlation, another Spearman rank correlation is related to positive correlation. And before understanding the Spearman rank correlation, we should know what is monotonic function. Monotonic function is nothing but it is one of that either never decrease or never increase as its independent variable changes. So this is all the theoretical part you all the students should know. Now we'll jump to the mathematical expression of that particular Spearman rank correlation coefficients. Fine. So this was the theory you all students should know. Before I'll teach you with the example of Spearman rank correlation. So I have already wrote it down for you all the students. Please note that theoretical part on your pen and paper if you have. Fine. So that you don't get confused what I'll teach you the next topic. So let's take the example now. So in my last like in that previous before erasing this particular topic on this whiteboard, I have taught you the formula of Spearman correlation coefficient. So after using that formula, if your value come, what I am teaching you, Spearman correlation coefficient. Look, if after using that particular formula, if your value came +1, it means what +1 means. If your Spearman correlation coefficient formula value come +1, it means perfect association of rank. So why we use Spearman correlation coefficient? We use how closely related two ranks are, how closely association of ranks are there. So if +1 is there, then we'll say that ranks are perfectly associated. If value came around 0, Spearman correlation value came around 0, it means by seeing the graph we can see that there is no association of rank. Fine. If Spearman correlation SRC, I'll write it SRC, Spearman correlation coefficient in short form. So if SRC came 0, then there is no association of rank. If SSC come -1, then there is perfect negative association. Now let's take one example here. I'll give you one example of how closely related these things are. 5 students in maths. Let's take example of students. 5 students in maths and science. Fine. 5 students in maths and science. Here let's suppose students, these are students. Who are students? A, B, are you able to watch it what I am writing here? A, B, C, D, E. They are 5 students. 1, 2, 3, 4, 5. Fine. So what is the score of maths for these students? Score of maths is 35, 35, 20, 49, 20, 49, 44, 30. And what is that rank? Rank of these maths if for 5 students. Fine. Who scored higher in among these 5 students in maths? Higher scoring is done by 49 marks. Students who got 49 is the number 1. Fine. So we'll write number 1 in front of that particular students. So that is number 1. Now you guys tell me the next second number rank who got the highest marks in maths. Second is that 44%. That is D. D got second rank. After that, who got third rank? A got third rank. Fine. And which is fourth one? E got fourth and B got 5 rank. Fine. Now what we'll see that after what is the marks gained by those 5 students in science topic. So science topic marks, let's suppose one got let's see, A got 24. Fine. And B got 35, C got 39, and D got 48, and E got 45. Fine. So what is the rank of rank? Now we'll see the rank of particular science topic. So rank would be, who is the number 1? Who got number 1 in science? D got number 1 in science. But in maths, C got number 1. Fine. But D got number 1 in science topic. That is 1. So who got second rank in science topic? Which student got second rank? It is 45. Fine. Second rank is here. Now C got third rank. And B got fourth, and A got fifth rank. Understand? This is the table, and this is the only data you student got. Data scientist got what data got? He got 5 students, and he got the marks of maths and science, and rest you all the data scientists have to calculate by using libraries. Fine. But I am teaching you here so that you understand the mathematical part behind these libraries, how these libraries calculate. Fine. How you would calculate, simplify. So this is the rank. Now we'll understand what is D. And as you all the students know, the formula of spearman correlation is, before erasing this particular topic, the formula I have taught you was 1 minus 6 summation of d I square upon n square minus 1. This was the formula. Fine. Spearman correlation coefficient formula is this. And now after we got 2 ranks for maths and science, and these 2 ranks, if we'll take the difference, 5 minus 3, what would be the rank for difference between, this is the rank D. Fine. So if we'll calculate students A rank in maths and science, how much his rank is, how much increasing or decreasing of the marks in the ranks of that particular 2 particular subjects is there for students A would be 2. Fine. There is 2 ranks difference. And for students B, what is the difference between the 2 particular subjects? 5 minus 4, there would be 1. Fine. And for C students, what is the rank difference? C would be 2. Fine. And 2 minus 1, 1. 4 minus 2, 2. This is the rank D. Now as we can see the formula, we have to calculate di square. Di square. So what we have to do here, we'll square that particular thing. Fine. We'll square that particular thing. So 2 2s are 4. Fine. 1 square is 1. 2 2s are 4. 1 square is 1. 2 2s are 4. So now what we'll do? It is saying summation. This particular sign is used for summation. So if we'll sum this particular topic, then it will be like di square. So what is summation? 4 1 5, 4 9, 9 1 10, 10 or 4 14. Fine. So what we'll do now, we'll apply that particular formula here. Apply that formula here. So after applying this formula, so what we'll get? What will get Spearman correlation coefficient? 1 minus 6 multiply, what is the summation of di square? 14. 14. And how many number of observation are there? Tell me. How many number of observation are there? 1 2 3 4 5. There are 5 number of observation. 5 students, 5 number of observation. So what is the formula? N. N is 5. And again is n square means 5 square minus 1. Fine. So that is 1 minus 6 4s are 24, 2, 6 1s are 6, 6 7 8. How much it would be? Around 6 4s are 24, 14 6, 6 4 2, 6 1s are 6, 8, 84. Fine. It would be around 84, and 5 minus 25 minus 1. So how much it would be? 1 minus 84 divided by 5 minus 24, and it would be around 0, 4, 83, 84, 1 minus 84 would be minus 83, 25 minus 4. That will be minus 19. So approximately answer would come. That would be approximately 0.3. Spearman correlation coefficient answer came 0.3. So what I have given you here, if Spearman correlation coefficient came 0, around 0, what our answer came for particular data? Our answer came 0.3. Fine. Here for that particular data, Spearman correlation coefficient is 0.3. How it is related? It is related to the 0. And what 0 means? No association of rank. No association of rank. Why there is no association of rank? Because it came 0. So by seeing this particular Spearman correlation coefficient value, data scientists, they don't jump into the whole part of that particular scenario, but just by seeing that particular topic, they would say that the two ranks which we got after using that particular data, they are not closely relatedly associated. They are independent to each other. Ranks are independent to each other. Maths rank is independent to each other for the particular students A, and science rank is independent to the particular students, science students, for the same students. So what does that mean? It means that the students who is good in maths, he is not good, it is not surely can say that he would be good in science also. So this is called Spearman correlation coefficients. Fine. If here monotonically maths rank is increasing, here monotonically science rank is decreasing for the same students. So this is called spearman correlation coefficient. So this is all for today's topic, and this is the finishing part of spearman correlation coefficient. Thanks for all the students who are studying, and I have finished the topic of spearman correlation coefficient. Thanks a lot for watching this video, and if you like my channel, please like and subscribe. And if you understand what I was trying to teach you about the spearman correlation coefficient in this particular video, please like and subscribe my YouTube channel. So this is for all. Please write it down on your pen and paper. So in my next topic of after teaching you the spearman correlation coefficient, I'll directly jump to the for the English medium students, I'll start teaching you the mathematical part of data science. Fine. This is all for spearman correlation coefficients. Fine. I hope you students without get confused, you understood what I was trying to teach you. So please, if you understood it, like and subscribe Pamita AI World. Thank you for watching.